quick disclaimer, this is not going to be an exhaustive presentation or the authoritative presentation on XCM v3. Uh, there is scantily available information, so we did our best and we hope you learned something. So just to recap, what is XCM? XCM is a cross consensus message format. So as you would know by now, and a message format cannot be transported from one place to the other without a protocol. So we have XCMP, which is the messaging transport layer, which transfers the bytes of XCM from a source destination, from a source location to a destination. So that is the XCMP message protocol. Next, we have HRMP. HRMP stands for horizontally relay routed message passing. So it's a light version of XCMP in the sense that it tries to mimic the behavior of XCMP, but it does so using something that is uh, not as efficient as it could be. So it doesn't use directly peer-to-peer message passing, but uses something called UMP, which is upward message passing, and downward message passing. So messages are actually stored and passed through the relay chain. That was in a, and the VMP basically stands for both terms. So VMP is like an umbrella term for UMP and DMP. And two new terms in context of XCMV3 that was coined by Gavin himself, GPMP, and that stands for Grandpa Protocol Message Passing. Now, what is this? It's a transport protocol for message passing between standalone substrate chains and a relay chain like Polkadot or Kusama, or maybe some of the parachains that are connected to a relay chain. So there we have GPMP, and finally SCMP. So which could stand for either substrate chain message passing or smart contract message passing. Basically, the messages are going from smart contract to a substrate chain over a bridge. So now we walk into the high-level overview of XCM v3. So as you might already know, XCM is a version messaging format. So it goes through iterations, it's constantly being updated, and as we speak, work is being done. So right now, XCM version 2 is live on Polkadot and Kusama, and XCM v3 is scheduled to be released in the next major update. So what does XCM v3 bring? So it brings three key features. I would say it enables three key features. The first is improved programmability. So what do I mean by improved programmability? So as you might know, XCM is already a sort of a programming language. XCM v3 wants to improve that by adding new instructions and features. So we can have something called expectations and branching. So what are expectations and branching? So just like in a programming language, you have if else, this circumstance and that action, that circumstance and this action. Similarly, the destination chain can respond to various circumstances based on the new message format. Finally, we also have introspection and safe dispatches. So programmability allows you to actually look into the destination chain and confirm whether when the message was constructed with the palette and what you call it, the message format versions, if they are correct or not. So it allows you to escape undefined behavior in a sense. And finally, asset exchanges. So XCM v3 enables asset exchanges, especially non-fungible assets. So that's for the programmability features. The next is multi-chain decomposition. So what the idea behind multi-chain decomposition is that there will be system chains, and system chains meaning just like you have palettes such as the governance palette, the assets palette, and they are all specialized in their own way. That functionality will be abstracted into parachains, and XCM v3 will act as an interfacing layer between these system chains. So that is multi-chain decomposition. And finally, we get to bridging. So what is bridging? Bridging is something that will allow XCM messages to be transported to different consensus systems over bridges. So, and this could be a series of bridges, so not just one bridge, multiple bridges. So that was the main highlights of XCM v3. Now we'll go on to the next slide and have a look at the diagram. This is basically the architecture of how everything fits into place. So we have XCM v3, XCMP, and the various transport protocols that will be running on parachains, smart contracts, and solo chains now as well. So over to you, Dom, for the details of the features.
Yeah, so the main features is related to what Abhishek just did in the beginning, a brief overview: programmability, functional multi-chain decomposition, and bridging. So we're going to see these changes. It's changes grouped together in these three main categories, and we're going to see them in detail. First, programmability. As Abhishek mentioned, it allows XCM messages to be more sophisticated, so make XCM a more programmable language, as Agav also explained in Polkadot Decoded. What does this mean? It means three subcategories in general: expectation and branching, introspection and state dispatches, and asset exchange and NFTs. For the first subcategory, what does it mean? Expectations. We have with XCM3, we have three new instructions. It's expect the asset, expect error, and expect origin that are related to the already existing registers holding error and origin. So expect asset, it checks if the register holding has at least a specific amount of assets, and if not, it throws an error. Expect error, as you can imagine, it also checks and throws an error if it doesn't find the corresponding value in the register error, and the same for expect origin. This is so expectations. That's why the word, but it was also branching, and branching means when we throw errors, it changes the flow. So instead of executing the instructions, there's an error that is thrown, and yeah, so that is how expectations is making XCM more programmable. Safe dispatches, as Abhishek mentioned, so safe dispatches, it's also changes that come with XCM3 that check and ensure basically the version of the destination chain and the versioning of the pallets. So we have, again, a new register, which is called a transact status register, and 4 new instructions: query pallet, expect pallet, report transact status, and clear transact status. The new register, transact status, actually holds the result of the most recent attempt of transact operation. Query pallet is an instruction that gives back the instances of a specific pallet, that specific module that we ask, let's say. So it gives us the instances. It's again related to versioning. Expect pallet is an instruction that throws an error if the version that we expect is not the same as the one that we get back. Report transact status, it reports the destination, what the transact status register holds. And clear transact status, yeah, it just clears the register transact status. Pretty straightforward. So yeah, these safe dispatches, that's why they are called safe dispatches, because the goal is to ensure that no unexpected behavior is happening, and yeah, everything is flowing as expected, or ensuring as possible that is safe and secure. Functional multi-chain decomposition is the second big category of changes in XCM3, and it's related to allowing mechanisms to be built logic. Yeah. So basically, make applications that can their logic can run on multiple parachain shards, and we can allow that with three subcategories of changes, which is remote looking, context ID for tracking messages and queries, and asset namespacing. Again, I will go in detail in the first two. So just to understand how this can be done, remote looking. This, I think, also in the code walkthrough, Frank will explain, so I will not spend too much time on this. Yeah, so it enables one chain to use assets that exist in another chain. The one that is most interesting, well, also, well, 4 new instructions we have with XCM3, lock asset, unlock asset, not unlockable, and request unlock. Yeah, one that is really interesting is the request unlock, which is actually another chain can request an asset that is in the first chain, like in the different chain, to be unlocked. Yeah, so I found it quite interesting. This can happen with XCM3. Okay, and the second subcategory, topic and context. So what is this? It helps track XCM messages? Yes. Is it the ID of an XCM message? No. But yeah, as it is stated also by Gov in a substrate stack exchange, it could be crafted as one. How? We have, for this, we have a new register, which is called topic. It can be set in any value. And for that, since we can set it in any value, we can use it as an ID when we could, and when we can use it as an ID by itself, but also when we combine it with origin, we can create a unique identifier, which is, yeah, that's a real actually ID. The second one is XCM context. XCM context actually is a struct with 3 fields. It has origin, the message hash, which is the XCM hash field, and topic. With these 3 fields, actually the XCM executor can know about the context of the instruction. So yeah, so yeah, that's about it. So yeah, basically with topic and context, this new changes. That's why we can have an application that is spread in different shards, because we can track and get the, what the XCM message is about with XCM context. Bridging, the third big category of changes, and the most exciting. Yeah, allowing XCM to function over bridges. In this one, we have changes that are related to the so-called new universal location, message exporting, 2-stage send and export, and logical origins. I will, yeah, I think I will mention the first 3, and a little bit of detail. Universal location. So yeah, how I understood it from the GasPR XCM version 3 and Polkadot Decoded talk. It's like so wait, I will just read first. It's a new and unique location, and it's like a parent of all locations. Locations, when I say it, means different consensus systems. So we have parachains, we have relay chains. It's above all of these, like as an imaginary consensus system, but there's no consensus system. It has no parent, since it's above everything. And yeah, the ancestry is deprecated, and it is so now use the context, which is the location of something within the universal location. Yeah, so everything is, since it's above all, it's the so-called, actually I don't remember right now, but it's in internal location, it's called, I remember. So yeah, that's why we don't need ancestry anymore. Yeah, the second subcategory in bridging is the message exporting. We have 3 new XCM implementations to manage XML messages over bridges. We have 3 new implementation because for the 3 different cases. When the bridge is local, when the bridge is in local consensus, but not on the local chain, and that does not require any fees. And the third case, when the bridge is not local, so we expect also fees to be paid. We have the new API export XCM. And this just to check, I think there's no more a lot of information. The best thing I think to check it is just to check the SendXCM implementations in the code. And then, the third subcategory is the 2-stage SendXCM in bridging. The SendXCM has been refactored to a 2-stage process. Validate, which means it validates and it does a price discovery, so how much will it cost, and returns the ticket to complete the operation. It doesn't execute, but in the second stage, deliver, it carries out the actual execution. That happens so we know what the payment is, and it should happen or fail prior to the delivery. So I think that's it. I will pass it now for a demo to Hector.
Okay, so thank you very much, Dom, Abhishek, and also Frank. So I will just recall what Abhishek was saying at the very beginning. Okay, there are a lot of things that we can mention about, like XCM, be free. Like for example, on bridging, we can go much in deeps on this, but this is a technology that is still being built. Okay, this is under development. So, and what I'm saying is, first of all, because this, we cannot do an exhaustive, review of the technology, but also because for explaining how the things work, we should go very deep in the code. All right, because there are no documentation yet. There's no documentation yet. There are certain behaviors that we still need to make our mind model. All right, so the way as I, for example, learned how the NFTs transfer works in XCM B3 was by just reading the deep code, and that's what we are going to do a little bit, because this also will help you, okay, to understand how this works. So when you have to use it, okay, you understand how this works. This is maybe a little bit a cons that XCM as a technology got, right? And it's forces the developers that use this technology to really understand how the things works under the hood. Okay, so having said this, what we are going to do is basically what I presented, okay, on Sub-Zero. To make it clear, I just renamed the parachain, okay, to match with the code. So basically what we are going to do is we are going to reserve-based transfer an NFT meter statement to the based parachain. All right. So now I will get a little bit more specific, and I will start talking about code. All right. So before starting speaking about code, just a little recap about what a reserve-based transfer is. And in the context of NFTs, what we are basically doing is on a statement, we are locking the NFT in the sovereign account of the parachain, of the base parachain in this case, and we create, okay, a representation, a derived NFT on the destination chain. So this is basically how cross-chain, transfer works in general in the blockchain industry. So when you send something, okay, in a cross-chain transaction, in general terms, what it's doing is it's basically locking the asset on the origin, okay, and it's minting a derived or a grab representation, okay, of the asset on the destination. In XCM terms, this is called reserve-based transfer. This means that on the reserve, we are locking it, okay, and we are creating a representation of the redive version on the destination. And this is basically what we are going to do with this NFT. So now, yes, we are going to speak more about code in Dips, all right? So we know, like, for minting NFTs or non-fungible tokens, what we use in our ecosystem mostly is the palette uniques, okay? And this is a very well-known palette because, for example, on StayMine, okay, this is used to mint our NFTs, right? So basically, you have a collection, and within the collection, you have different NFTs, okay? So in the palette uniques terminology, that collection ID, okay, contains items IDs, okay, which is the NFTs of what we are going to use in this case. So if you go, for example, on a StayMine, okay, and you read the configuration for how this palette is configured in the runtime, okay, you will see that collection ID and the item ID are Rust primitives, like I think U32, okay? So if you pay attention in here, and this shows how much powerful Substrate is, you can change the type that you provide to the collection ID and to the item ID. And in this case, we are providing a multi-location to the collection ID, and we are providing an asset instance, okay, to the item ID. And these two types that we are providing are XCM types, are XCM primitives types that we provide to the palette uniques. Basically, what this will do, this configuration change will do, is like when we have, okay, on this destination, we have the collection, it will not be pointing to a collection that will exist locally, all right, on the chain. So it will exist. There is like an storage item representation on the destination chain, but that NFT or that collection, sorry, that will be pointing through the multi-location of XCM to the origin, all right? And this is a very important change in the configuration on this palette. And then the NFT itself, which is the item ID, it will be configured using the asset instance, okay? So this asset instance is basically, again, how XCM, right, through the asset transactor, basically manage the NFT, all right? So instead of saying U32, well, the ID is going to be, I don't know, free, okay? The item ID will still be a free, but in terms of the asset instance, not like a U32. It's an XCM type that we are providing here. And lastly, which I think is very important, we are on the create origin type, okay, where we say like who is allowed to create these like NFTs and collections. We set the foreign creator type, which is a type that restricts to create, collections and NFTs, all right, locally. So I cannot go directly to the destination change and create the collections on my own. Not at least on this palette and how this palette uniques instance is configured. This is why we call this a foreign unique, all right? So these are like just instances, NFT instances that are just created from an XCM message, right? So this happens thanks to the foreign creator type that we are passing to the create origin. And if we read a little bit, a code or the example code that we have implemented on Trappist or the base parachain as well, is like we define the foreign creators, all right, implementing the ensure origin with our trade. And basically we define these two like types, the tried origin and the successful origin. And here we are saying, okay, for allowing the creation of these items on the foreign uniques, configuration, you need to go through this code first, all right? So basically we are saying it has to be an XCM message, and this is what is happening on the sure XCM everything, okay? That's basically what this code is doing, restricting like the instances that are going to be created on this palette just are allowed if they come from an XCM message, okay? All right, this is a big thing. And I think like maybe you went through this explanation or what this type is on the previous learning sessions on XCM that Bernardo did, but I will do a refresh because basically this is exactly what makes the magic to happen in terms of how do we configure the NFT, all right, in terms of the XCM B3. So we have something when what we are configuring XCM on our parachain, we configure the XCM executor, all right? And the XCM executor, what contains specifically for assets is something which are called asset transactors. Okay, I don't know if you got the chance, but there was an interesting discussion on the Substrate channel on the what is now the All Elements server. And it was like a very interesting explanation from Gav saying what XCM is and how basically the assets are managed in XCM. And basically he says that XCM is an off-chain process, all right? So basically there is like a glue, all right, regarding the off-chain process of XCM and the on-chain logic on our runtime. Okay, and that glue is basically the asset transactor configuration. So when we transfer an asset, it doesn't matter what kind of transfer we use. What is happening is like we are like destroying that asset, okay, on the on-chain logic on the runtime, okay, and we are putting it on the holder register of XCM. And when that process is happening, basically we are like starting an off-chain process, which is XCM. Okay, XCM is an off-chain process, and the asset transactor basically says how that process is happening. Okay, how that transition. Let's better use the term transition is happening. All right, so we have different kind of asset transactors, different transitions behaviors that we want to define for these transitions when the assets get from the on-chain logic to the off-chain logic of XCM. And these asset transactors, right, are the local asset transactor, which is basically how are we going to behave with our native token of the chain, like in the case of Statement is DOT, in Statement is KSM, or like in the case of Moonbeam, for example, is the GLMR token, all right? Then we have the reserve fungible transactor, which this is a kind of a transactor that we define on Trappist, where we said, okay, we recognize a statement, okay, as a reserve for our assets, okay? So we configure one specifically for this. Then is the local fungible transactor, which is how we deal with assets which are defined on our local environment, on our local chain, okay, from the assets palette. So for example, if we are in Statement, okay, the local fungible transactors is the transactor that will interact with USDT, for example, or RAPBTC, or any asset deployed on the palette assets, all right? And finally, this is the one that we need, okay? This is the important one for the NFT use case and the demo that we are going to use, which is the Statement non-fungible transactor, all right? This is an interface that basically will know how to interact with the foreign Unix, okay, palette with the off-chain XCM logic that will transfer the NFT, all right? So this is like basically the way as you define it on your runtime. So the Statement non-fungible transactor uses something called non-fungible adapter, all right? So this type, the non-fungible adapter, is a type that comes from the XCM builder, all right? And we provide a certain types of input types. And if you check the first one, is the foreign Unix, all right? So when we configure the non-fungible transactor, we need to provide which component are we going to use on chain to handle these NFTs transfers, okay? And in this case, and you can see, we are providing the foreign Unix, okay? Which is the one that we saw before, where we put like the collection IDs, the multi-location, The creator ishing is the foreign creator, and all that logic that we were describing before. And I know that this might be tricky, all right, but we need to understand how all this process works, okay? And we need to go into the code of the builder in order to understand what is happening when we are sending an NFT. So this non-fungible adapter struct implements, okay, the non-fungible, the transact asset, all right? And the reason why I put this code is so you can see which are the types that are being provided, okay? So the assets instance that is provided here, the assets type that is provided here should meet with the requirements of the mutate or the transfer, okay? And all these types are included on the palette uniques, okay? They are like, the palette uniques meets these requirements in terms of like Rust types expected on this type, okay? So if you check like the, the methods which are inside this non-fungible adapter, you will see like there is a common pattern, which is like, when I call the deposit asset instruction, what is happening is I'm calling another struct, which is the non-fungible mutate adapter, and I'm calling the deposit asset. So we can say that the non-fungible adapter is a wrapper for the non-fungible mutate adapter, which is the one that makes the magic and executes the on-chain logic, all right? This is the glue in other terms. So for the withdraw asset, it happens the same. Basically, we have the non-fungible mutate adapter coming into the scene, all right? And it's calling the withdraw asset. So in order to understand what is happening, I think that we should like review the code for the mutate adapter, all right? So if we check what are the types that this non-fungible mutate adapter is required, is again asking for assets, a matcher, account ID converter. All this comes from the XCM config file that we provide, all right? So if you check like the path, you will understand which kind of types are required here. So what I wanted to show, I mean, all this like explanation and this like, top-down hierarchy that I'm describing here is because what I want to show is something very specifically. For example, when we do a withdraw asset on the reserve, what is happening is like the asset is being burned, right? And I don't know if you are able to see it here. Once like the, we identify who is basically doing this and if it is allowed or not. Like, for example, if you like, for example, try sending assets and you go to the logs and you will see the account ID conversion failed. This is a kind of error that appears a lot in the logs, comes from this part. And all this code that I'm showing right now is the XCM builder. The XCM builder, okay, is the glue that knows how to interact, how to use the asset transactor configurator to basically interact with the on-chain logic, right? Which in this case is going to be the palette uniques that we provide. So what I want to show in all this top-down, okay, hierarchy is like when I do a withdraw asset, I'm burning the asset, okay? And this is happening on the assets burn. So I have to provide an implementation that gets like contains a burn method, all right? In this case, this asset dot burn is the palette uniques burn method. So this is going to destroy, the NFT. The same happened with the deposit assets. It's calling the mint into, all right? And you will see this in the logs when we execute the transfer of the NFT from StateMine to the base parachain. That was all the code related. What I will do right now is do a demonstration of how we transfer the NFT. And we will go through the events and we will understand based on this explanation I did, all right? So I'm on StateMine, okay? I have, in this case, I have the Unix, okay, instance. It's not a foreign Unix. In StateMine, I have the proper Unix instance. And I have this collection ID one with an item ID 77. So basically our NFT, okay, contains the item ID 77. All right, I'm basically demonstrating that the asset exists on StayMine. So the first thing we need to do is we need to create, all right, the collection first. But I told you that it's not possible to create locally, right, the collection. So what I'm doing in this case with the pseudo palette on this parachain, I'm like forcing to create the collection. If you ask me what is like the best approach to create this like foreign collection, would be executed a proper transact from StayMine, all right, and we might, like, for example, set, I don't know, like the owner of the collection might be, for example, the sovereign account on StayMine on the base parachain, I don't know, or whatever that we need. For just simplicity and to not make this much more complex than it is, so basically I will just force the collection creation with the pseudo palette. All right, this will allow me. So if you see the collection in this case, I'm providing the multi-location, because remember, when we configure the foreign uniques, right, as you can see here, now it's asking a multi-location. It's not asking a U32. So we need to provide a multi-location, which in this case is the parachain 1000. I will go here. Is the parachain 1000, which is a StayMine, and the general index 1, which is the collection ID 1. All right, and the owner in this case is going to be Alice, right? So we execute it. All right, so we have in this case, in the event, we see like on the base parachain, we have the foreign collection created. And now let's go to a StayMine, and what we are going to do is now, yes, reserve-based transfer the NFT, all right? So we are going to use this extrinsic, which is the limited reserve transfer asset that we know it already, because these extrinsics exist already on the B2, on XCM B2, and we use this for transferring assets, right? So basically here we are saying on the destination that we are going to send it to the parachain 3000, which is the base parachain. The beneficiary, this is not new. I mean, we are like referring this to a Bob account using the account ID 32 format. This is important, all right? So we are going to, I mean, in this part, the version multi-asset is an array, and we are going to write two types of arrays, all right? The first one is a fungible type, which in this case is like, is an stable coin, let's say, is an asset, ID 1, all right? And the reason why we are like providing this fungible token at the really beginning is to pay the fees with an asset, right? Not with a native token. That's a process that comes from another explanation, all right? Or I don't know if you did it on the previous, if you have the time to review it on the previous presentation, but you can pay the fees of an XCM message with an asset that is not the native token, right? In the case of a StayMine, you can pay it with USDT. So this is like the equivalent on here. And the second one, the second asset that we provide in this array is the NFT, okay? So we provide on the general index 1, which is like the collection ID 1 that exists, in this case, on the Unix palette of a StayMine. And we are like on the fungibility type, we are saying a non-fungible. So this will basically call the non-fungible adapter that we reviewed before. And on the index, we are saying which is the ID or identifier for the NFT. In this case, I don't know if you remember when we read the storage item, we are using the 77 identifier for the NFT. So we are going to execute that. The good thing about the video is like I can go forward. Okay. All right, good. So what is happening here, right? All right, this is what I want to show first. So take a look, like the Unix, okay? You receive, like, you see the event, like the unique was burned, all right? So the instance of the NFT was burned from the Bob account, And what is happening is like it's being remint on the sovereign account of the base parachain on the statement, and you see it here. So that's the first thing like XCM do, right? For moving or for locking the NFT on the reserve chain, what is happening is like burning it and then minting it into the sovereign account. And this happened because of the XCM builder, right, with the non-fungible adapter and the mutate adapter that I demonstrated before. Okay. Now that we see like the message was attempt, we are going to go to the base, parachain, and what we are going to see is like the message was received, and indeed now the foreign unique, the instance, I mean the NFT per se was mint on the base parachain, okay, because of an XCM message that was received. And we can see here, like we received the event, okay, for the NFT. And if we go now on the storage for the foreign uniques, and we provide the multi-location for the collection, all right? We provide the collection ID 1, let's say, and the index 77. We can see that the NFT was now created on the base parachain, on the destination parachain. But if you just take a look of the values we have provided, they are pointing through the multi-location to the origin chain, to a state mine. Okay, it's pointing to the reserve. All right, we are running a little bit out of time, so Frank, I leave this up to you now.
Right, so I think that looks good. So firstly, just to kind of highlight what we're looking at. So we've based kind of all of this on Gav's branch within the Polkadot repository. So if you're interested, it's gav-xcm v3. And as you can see, there's still work is still underway. Every time I kind of reload this up, there's more changes to sync. So it's still very much a work in progress. So the first thing just to quickly look at is just the differences in the versioning. So this is the diff between the current master version and v3, and you can kind of see that v0 and v1 have been dropped. v3 has been introduced latest as we move from v2 to now point to v3. And interestingly, there's a new module or namespace called LTS, which presumably is something like long-term support or long-term servicing. Then the next item I just wanted to sort of raise is something that Hector highlighted, which I've found very useful in kind of getting my head around all this, and it's something called XCM Simulator. So really what it is kind of like a little testing framework, much the same way that you write your mocks and your tests when you're doing a palette. You can do the same thing using this XCM Simulator. So you can see here, I've just got a type alias just to link into it. But the idea is essentially you define your network using this macro. So we compose it with a relay chain and two parachains with IDs 1 and 2. And then we can define the relay chain, which has a runtime and XCM configuration. And then we also have our parachains, which are both effectively the same with their own runtime and message queues for inward and outward bound messages, as well as the identifiers of 1 and 2 for those particular chains. So if we just go back, then the next item is essentially the XCM executor. Obviously, kind of the most important thing because it processes the various instructions. So this is just a pointer, so I can quickly and easily get into where the particular instructions are processed. So I'm just going to bring that up for later. And then go back. Another thing to mention on the XCM simulator, in this examples palette that they crate that they provide, is that there are various tests available which kind of describe how things work quite nicely. So it's kind of, I found quite an interesting way to kind of see which parachains are passing messages to different chains and how it all kind of works. So if we just, for interest's sake, just quickly run all these tests, you'll see that effectively every test has some detailed output, which is useful for kind of debugging. And then if we just search within that for process, you'll see these process instructions. So it's a nice and easy way to sort of visualize by running it and then seeing what the actual impact of it is, as well as the different aspects of the components being passed around, because the different instructions are sort of serialized out there for you so you can review it. And then you also see in the executor that XCM process instruction is kind of where it all ties in. So that's really just to kind of frame it all, just so it makes things a little bit easier to demonstrate and walk through. So the main two sections I'm going to focus on is programmability, sort of briefly, and then the remote locking is a little bit more involved. So if we look at the programmability first, so as mentioned at the beginning of the session, there was kind of these new instructions, which I'll just briefly review. So expect asset just takes one or more assets, which you obviously need to check to see that they exist. Expect error, as you'd expect to see a specific error condition exists. Expect origin, the same, checking for a particular multi-location. Expecting a palette, which we'll see demonstrated next. This is a little bit more interesting because you can pass in various criteria, which is expected to be there. So essentially, what indexes the palettes within the runtime, the particular name within the runtime. So when you use your construct runtime, you typically give it a name, and that's the name there. The module name, which is the palette's name itself. So palette underscore balances as an example. The major version of the crate, and then the minimum minor version of the crate. So in other words, minimum plus is what we're looking for. Go back. And then finally, reports error. Essentially, this was kind of neat in the way that if an error condition happens, we can report that to some destination. So if we go into it, you can see here that when it occurs and we're reporting the error, we can configure it where this particular message should be routed to. And we also have a query identifier, which we can use to sort of correlate or discern between messages, and then obviously the standard weight stuff. So if we just go back, so those are the kind of the instructions, and then just two sort of tests which demonstrate how these sort of expectations can work. These are just sort of two ones that I added very briefly last night. So the first one, so what we're going to do here is parachain A is going to send a message to query that whether the balances palette exists on the relay chain. So you can see here the context is parachain A, and within it, we're going to define our XCM instructions. Now, in this scenario, we're firstly going to set up our error handler. So this really is kind of where the branching happens. And similarly, you could use the appendix register as well for this. So in this instance, if there's an error where the palette isn't found, I want to send a message to parachain 1, which is parachain A, in other words, back to itself, notifying the parachain that we couldn't find this particular palette. The query ID doesn't really matter in this particular example. Then the next instruction, which is obviously the most important, is querying to see, well, expecting to see that there's a palette with these settings or criteria within the relay chain runtime. Now, for this example, I intentionally set the index to a really large number because the palette wouldn't necessarily be measured, wouldn't be associated with that index. And then I query the balancer's name, the palette balances, the version, and the minimum version as I described before, and then just some other instruction that follows after that, which shouldn't happen because the palette doesn't exist. So kind of saying, well, we expect the balances palette to exist. If it does, we want to withdraw an asset from it, just as an example. So the next step thereon is to obviously send the message. So we are using the parachain palette XCM to send on that message, and all that's really doing in terms of like the mock test up is kind of forwarding that message onto the XCM executor, which I'll drop into next. But interestingly here, you'll see that the destination is the parent of the parachain, in other words, the relay chain. So if we bring up the executor and we just look at the expect palette handler. So essentially this is processing the instruction for expect palette, and all it's doing is obviously it's, taking all that information, and then it's calling into the config palette instance info to query all the palettes that are available in the runtime, and then matching based on index. If it's not found, it returns an error. Otherwise, matching on name, module name, version, minor version, with each case returning an error. So obviously, if we've got an error, that gets put into the error register, in which case then we can use the error handler, which I mentioned before, to then trigger off the sending of another message to another parachain with the result of this particular call and the corresponding error. So if we just go back to that, to there. So that was the first portion where we're obviously just sending our message off now to the relay chain. Now the next phase is essentially we want to validate to see that we've actually received that message. So all this is doing is on parachain A, it's looking within its local message queue to see that it's received a downward message. And then that message that's in the queue matches this particular response. So in this instance here, we're looking for a query response, and the response is the result of an execution. And in this instance, we're making sure that we receive this particular error, which is pallet not found. And the reason being is because obviously I passed in this large value above. Another interesting thing as well is we've got this new concept of querier, and essentially that's the person that kind of triggered off or instigated this whole process. In other words, the original initiator. And these additional sort of attributes allow us to kind of discern which messages are coming from where and to sort of correlate them together. So that's pallet expectations. The next one will be querying a pallet, which is kind of very similar, but just a few additional aspects to it. So in this example, we specify a query ID in advance because we pass that in when we're querying for the pallet, and we can obviously then use that query ID later on. And in this one, we're just querying to see if a pallet exists with the name of pallet balances. You can see in this example, that's the only option that we get. We don't get any of the additional like crates versioning criteria that's available to us. But more importantly, when we query the pallets, we have to specify where we want the response to go. And in this example, we decide, okay, let's do something more exciting. We want to deliver this to parachain B or parachain 2, passing in the query ID. And then the same thing happens. Obviously, we just call into the XCM instructions, which I'll sort of skip over. Actually, let me go into that very quickly. So it's a very similar thing, but you can just see there, it's just calling through the pallets, filtering it based on the module name, returning the pallet info into a vector. And then once it's got that information, constructing the query response message with all the information that we pass to it, and then finally sending off that response to the destination chain. So if we get back to, sorry, that one, losing my place here. Okay, so that was obviously sending it off. And then secondly, now we check on parachain B to see if we've received the query response message, which includes the pallet information that we expect. So you can see I've just put in some configuration here for the expected pallet balances being an index 1, and all the sort of additional information that you'd expect to see. In this instance, this test passes because the message that's received in the downward message queue from the relay chain contains the information, which is a response type of pallet's info, and it contains a vector with the expected pallet. And the next two items aren't really applicable here. So that kind of shows you how you can kind of query for pallets and send the information around, and then based on where the pallets exist, have expectations, which allow you to branch and kind of structure your logic accordingly. So that's it from the programmability side. There is also an instruction for reporting a transact status. I won't get into it for the sake of time, but really all it's doing is it's saying execute some transact on a chain and then take the status of that and send it somewhere else, report it in the same way as we did with the pallet querying. So on to the next item, which is remote locking, and there's a bit more meat to this one. So if we just quickly review the instructions for context. So really we've got lock asset, and that instruction takes two parameters. First is the asset to be locked, and then secondly, and more interestingly, is the unlocker, which is some location, which essentially has permission to unlock this asset sometime in the future. If we go back, we've then got note unlockable, and really what this instruction is just a notification that some asset has been locked somewhere else, And we've been notified to say that we have sort of control to unlock this asset on behalf of the owner at some time in the future. Then we've got request unlock, which essentially requests an unlock on some remote location, again, assets and the locker. And then finally unlock assets, which removes the lock of the asset for some owner. So those are the instructions that will get processed. Then the process that sort of handles all this is the asset locker via the asset lock traits. So if we just have a look at that very quickly. So the asset lock traits, as sort of Dominique mentioned, there's this whole sort of two-phase approach to all these sort of messaging primitives, and they all use something called a ticket. And another way of thinking it is kind of like a JWT or JSON Web Token. So the idea is that you'll sort of request something, you get a token back, and then using that token, by holding that token, you can then use that token to enact some other change sometime in the future. That time in the future could be, a few statements within a code block. So just as an example, looking into this trait a bit more, so we've got prepare lock, which essentially is going to perform some checks before we actually get the lock, and then it's going to return a lock ticket that allows us to then call enact on the ticket when we actually are ready to enact the lock. And then a similar function is available for unlocking, where we first prepare to unlock it, and that again is just going to validate it, make sure everything's as expected, the state is correct, returning an unlock ticket or lock error. And then finally we've got two more, note unlockable, which is handling a lock notification from some other chain, and that's basically just the internal processing or sort of doing the bookkeeping or state changes within the palette to handle that. And then finally we've got prepare reduce unlockable. The difference between sort of unlocking is sort of unlocking the whole amount, where reduce unlockable is only reducing the amount of that locked amount, in other words, unlocking some portion of it. So that's the sort of trait, as it were. Then just to delve slightly into the asset locker implementation, and this is in the palette XCM. So this gets a little bit complicated, so hopefully we can get through it quite quickly. So if we first look at the prepare lock that I mentioned before, so really kind of all this is doing is its internal state management to handle this whole locking process. So if we start off, we firstly get the sovereign account of the owner, of the assets. We then ensure that the asset actually exists within the sort of local chain, and that there's a free balance for the sovereign account that matches the amount that's going to be unlocked, which is there. We then check to see if there's any existing locks for that particular locked fungible, and that's using the sovereign account. And then once we've got all the locks for a particular sovereign account, we then check to see a particular position for a particular unlocker. So the unlocker would obviously be some remote chain that has permission or rights to perform the unlock. If it doesn't exist, then we obviously hold on to that item index, and that goes into the ticket, because that information just gets used later. So if we go back, so that's preparing the lock and getting a ticket. The next stage is obviously to enact the lock, and you'll kind of see in the next one now why we have the prepare. Actually, it comes into the instructions on the base, which I'll show you. So this is enacting a lock. So the first stage, obviously, preparing the lock. So first things first is we check to see if there's an existing lock for the sovereign account. And then we check to see if there's an existing lock for the unlocker. And if there is, then we update the amount for the unlocker. So again, as I said earlier, just sort of bookkeeping in terms of what is locked and what we're aware of. If it doesn't exist, then we just add the amount into the unlocker, or add the amount and the unlocker, sorry, into the locks, and then we add all that information into the state of the palette. Good thing to keep in mind is that obviously all this is happening within the palette XCM sort of context and its own state. So we sort of tracking what are the locks that we have for this particular sovereign account, and each of those locks pertain to some unlocker, which is some other foreign chain. or accounts on that chain. And then finally, once we've got all the information sort of sorted through, the next thing to do is actually to extend the lock on the local currency. Now, to do this, we have to provide a lock identifier. And in this case, we're just providing this sort of palette identifier, which is just XCM LK for lock. And that's basically just kind of labeling to say that, you know, the sovereign account has got some amount locked for a particular lock identifier, or in this case, it's the palette. So that's sort of preparing the lock and enacting it. You'd be delighted to know that the prepare unlock is pretty much exactly the same. So I'm not going to go through any detail. The only difference here is that it returns an error if there isn't already some corresponding lock, which obviously would have happened in the previous sorry, excuse me, in the previous phase. So if we just go back, so enacting the tickets. So this again is just retrieving the locks for the sovereign account from the palette state, and then it determines the locked amount for the unlocker. And then based on that, we either reduce or remove the locked amount. So you can see it as a saturating subtraction of the amount from the locked amount. Or if it's 0, then we just remove the lock from the state completely. And then finally, at the bottom, as you'd expect, we just update the local palette lock state. And then we set the total locked amount, again, for the palette identifier or lock identifier, the sovereign account, and the amount locked. So really, just to sort of reiterate, this is kind of all just the bookkeeping of the locks and how much has been locked per unlocker, all within the palette XCM. So just go back. Then the last two, which are a little bit easier. So note unlockable, really, so this is just sort of dealing with a notification from outside to say some amount has been locked, and you're responsible for unlocking it. So again, we're just going to take that information and firstly check to see that the remote lock and the asset matches our trusted lockers list, because we don't want to just accept locks from anywhere. Interestingly enough, you do see here as well that for non-fungibles, it returns an error of unimplemented. So whether that's a to-do yet, or possibly for a future version, remains to be seen. Just a slight change here is we sort of unwrap the multi-location slightly by removing the network ID, and this more so is just a case of being able to sort of store the state accordingly, so it's easy to figure out who the lock belongs to. Then finally, we just create a record of the remote locked asset, and we just use the account, the sovereign account, the locker, the owner, and then a sort of a versioned asset identifier, and all of that sort of forms a tuple, which forms the key. So this is now just creating a remote locked fungible record, and really this again is just keeping track of some amounts of tokens or asset that has been locked elsewhere that we need to keep in mind internally in our parachain, so that we know that we have access to unlock it. So that's why we have this remote locked fungibles state. Then finally, the last part of it here, which I thought was quite interesting, is we check to see if there's any existing state. And if there is, we preserve it. Otherwise, we return a really neat sounding error called wood clubber. And then the last step of that is obviously to insert that into our local state so that we can keep track of how much remote locked fungibles we're aware of. So if we go back, then finally prepare, reduce, unlockable is just dealing with a reduction in a locked amount. I'm not going to go through all that for now for the sake of time, but again, the same pattern happens where we have a ticket and then we enact it. So just to finish off then, if we then actually look at the test, now this was an existing test that was provided in this example palette. And I thought it was kind of a neat way of describing it, and it's kind of why I've presented this whole thing in this way, is it kind of makes things a little bit easier to understand, because we're getting rid of nodes and everything else. We're just looking at the sort of the raw XCM messages that have been passed around and what sort of context those are. So this example, we're just going to lock 100, and we're going to start off by executing this within the context of parachain B, and we're going to create an instruction to lock an asset, and that asset's location is specified as here. And it's interesting, here is interpreted as the consensus system where the actual message is going to be executed. So in this instance, it'll be the relay chain, even though we're triggering the message to be sent off on parachain B. Obviously, we've got a locked amount, and then we then specify our unlocker as being parachain 1 or parachain A. So this is going to be executed by Pallet XCM, and is again can call into send XCM again. So if we look at the XCM executor, which is going to execute this locked asset instruction, which we can go to here, and then go to remote locking, you'll see here's the instruction here. So this is the handler which takes lock asset, and it takes in an asset and an unlocker, and it does a few sort of interesting things. The first thing is it takes the information that's provided and it tries to re-anchor it. So if we sort of jump into that, you'll see that it's taking these multi-asset and multi-locations, and it's using the concept of this universal location, which is defined in config, to sort of re-anchor the assets and multi-location accordingly. So it's taking some remote assets via some multi-location and kind of mapping it into some sort of a form that we can understand for execution locally. Then we get our lock ticket using the asset locker as described previously. Some more re-anchoring there. Then we create a message with the nodes unlockable instruction. Now this is kind of what I tried to mention earlier, is that you can see now we've got sort of almost two different processes running almost in parallel, which are kind of somewhat dependent on each other. But that's the kind of the main reason why we have this whole ticketing pattern, is that we can kind of kick off a bit of a process with some information, validate it, and then once we've got that information, we can pass a bit of that information to another bit of a process, and then once that process is validated, we can then enact the first part of the first process and get that running, and then finally finish off by enacting the ticket of the second sort of sub process. So as I said, we create the message with nodes unlockable, and that's going to be sort of sent off to the parachain, which is going to be the unlocker. So it just creates the message there. It validates the send, and in doing so, gets a ticket as well as a price for the fees. It then takes the fees for actually sending off this message to the remote parachain to notify them. And then once that's all kind of validated to be correct and we're happy, we can then enact on our original lock ticket, which is actually locking the assets locally using the asset locker. And once that is successful, then we can actually then deliver the nodes unlockable message by the XCM sender. So I hope that kind of makes sense as to why things are sort of structured the way they are. So if we just go back. So that's essentially now how we've created the lock instruction on parachain B. We've sent it to the relay chain for execution. The relay chain is obviously going to receive that information. It's going to lock the asset. It's then going to send off a message to wherever we configure to notify that some asset has been locked. And as mentioned in this instance, it was parachain A. So that's the first phase. The next phase is fairly straightforward. It's just checking to see that on the relay chain, using the pallet balances, that we've got a lock for the corresponding child account for parachain 2 or parachain B. And then we compare that lock with what we expect. Is it locked by the XCM lock identifier from the pallet XCM for a particular locked amount? And reasons are sort of matter less. And then finally, just to conclude, we need to just check to see that parachain A has actually received a message to say that it's been notified that it has permission to unlock some assets on a remote chain. So all this is doing really is just parachain A is checking the message queue again for a particular message or a particular instruction, which is not unlockable. And in this instance, it's parachain 2, is parachain B was the owner. But that's where we sort of kicked off this whole process. And then finally, that the asset is on the parent or the relay chain for the locked amount in the beginning. So that concludes the code walkthrough. I hope it was sufficiently clear. I think we can leave it there.
Thank you, Frank. That was amazing.